Good afternoon. My name is Michaela Williamson, and today I will be presenting over the article titled, "The Red Pepper's Spicy Ingredient Capsaicin Activates AMPK in Hep G2 Cells through CAMKK Beta." Listed here are the authors. And the main reason that I chose this article was as I was going through different articles and looking for one, I noticed that this one talked about a red pepper, and I thought that was really random, so I clicked on it. And when I noticed that the main ingredient that makes it spicy can activate things that are in cancer cells and just do so many different things, I thought that was really interesting. So I just wanted to learn more about that. So this paper focuses on whether the active ingredient capsaicin can activate AMPK in these certain cells, and if it can, what are the outcomes after that happens. So let's get started. First, I want to start with what is capsaicin, which is in the paper referred to as CAP. So throughout the rest of the presentation, I might say CAP or capsaicin. It belongs to the capsicum genus, and it is just the main ingredient of spicy peppers. And shown here is just a molecule of capsaicin. It is a natural alkaloid within organic compounds that contains nitrogen atoms. And capsaicin displays anti-tumor activity along with enhances cancer cell sensitivity to cytotoxic drugs and also reduces insulin resistance. Next, I want to focus on what is hepatocellular carcinoma, which is referred to as HCC within the paper. And basically is the most common type of liver cancer. And as you can see here, the cancer cells are going to start within the center of the liver, and then as the cancer progresses and gets worse, that cell is going to continue to grow until it reaches the outside lining of the liver. It is most prevalent within chronic liver disease such as cirrhosis, hepatitis B, and hepatitis C. The liver cancer cell line that they're going to focus on within this paper are going to be the Hep G2 cells, which are shown here. And those are just going to be an immortalized cell line of that human liver carcinoma cells. So next, what is AMP activated protein kinase? In the paper, they're going to refer to that as AMPK. Basically, it is a metabolic sensor of the cell energy status. So to activate that is through phosphorylation, and that's what it's regulated by. And a couple different upstream kinases that can phosphorylate to activate within the paper are going to be the liver kinase B1, which is going to be LKB1, and that is shown here. And then calmodulin dependent kinase type beta, which is CAMKK beta, which is shown here, which involves calcium activating that. And both of them are going to end up phosphorylating the threonine 179, and then in order all of that will activate the AMPK. So AMPK is a therapeutic target via metabolism and also signaling regulation, and they wanted to see if the AMPK could reduce cancer production or progression. Next, what is acetyl-CoA carboxylase, known as ACC within the paper? It delivers an acetyl group through the citric acid cycle, also known as the Krebs cycle, which is oxidized for energy production. And it regulates fatty acid synthesis, which is shown within this figure, and also fatty acid degradation. And I picked this figure mostly because it shows all the different things that I've kind of talked about so far, such as the AMPK either being active with the phosphate or inactive, and how AMPKK comes in play with this, along as the CAMP-dependent protein kinase, and how all of this flows with the acetyl-CoA carboxylase either being active or inactive with that phosphate, and how it all comes together. Next, what is CAM-dependent protein kinase beta, known as CAMKK beta? It regulates the appetite-stimulating hormone, which is known as the neuropeptide Y, and it functions functions as an AMP kinase within the hypothalamus. In this figure, you can see how the CAMKK beta is stimulated by the calcium, and then that would activate and deactivate within the AMPK. And you can also see the LKB1 that I mentioned before and how they all come together and how either one of these could end up activating the AMPK. In a previous study, they actually looked at the CAMKK beta, and they noticed that the inhibition within mice and how it reduces appetite and also promotes weight loss. So now I'm actually going to get into the actual paper, and I picked the first section within the results because to me that was the most important. If they didn't prove that section, then they couldn't have went on with furthering the study, and they couldn't have found anything else that they found within it. So to me, that's why I focused on that, and I thought it was the most important. So that section, they wanted to prove, can CAP modulate or activate AMPK within HCC HepG2 cells? So the method used within this was Western blot. So first you're going to run a gel through gel electrophoresis, and then once you have your proteins present, you're going to transfer those proteins to a PVDF membrane. You're going to block the non-specific sites that you do not want to see, and then you're going to use a primary antibody to target the protein, and then a secondary antibody to target the antigen. And then you will get your final product after all those steps where you are able to detect the protein and then analyze your protein from there. So through their Western blot and their techniques and information, they were able to see that capsaicin does activate the AMPK in HepG2 cells. So the cells that they used were incubated with capsaicin for a certain amount of time. And then they were able to determine that AMPK phosphorylation did occur at 3-amine 172, and phosphorylation of the downstream target, ACC, also did occur. So within this Western blot, they used beta tubulin as the standard, and when neither was present, this was the result. So then once they used capsaicin with those incubated cells, you can see that there was phosphorylation. And then once they used dorsomorphin, which is an AMPK inhibitor, there was not as much AMPK activated, but still a little bit. And you can also look at the protein levels within this graph that they based off of this Western blot. The light gray is going to be the AMPK, where the dark is going to be ACC. And you can see that once again with capsaicin, there was an increase in both from the original. And with dorsomorphin, along with capsaicin, there was a little bit of increase AMPK, but not quite as much. But there still was an increase with those protein levels. So based on the previous studies, they were able to conclude that capsaicin does demonstrate an anti-cancer effect, but the mechanism was still unclear, so they wanted to look more into that. And then it did show anti-obesity properties and increased energy expenditure. But they wanted to look more at the AMPK route through the homeostasis of the cell metabolic cells regulation, and they wanted to see if it really could help as like a cancer regulation strategy or prevention strategy. So this study ended up concluding that CAP does increase phosphorylation within AMPK and ACC, and the mechanism involving CAMKK along with calcium was the correct mechanism. And AMPK activation by CAP is involved with the mechanism of capsaicin-induced cell death. And in this figure, it just shows all together how once calcium activates the CAMKK beta, the AMPK or the inactive or active form of AMPK is shown and shows how it all just regulates together. So for some future research, I just think that it would be a good idea that once they have shown that the activation of AMPK by capsaicin has a molecular mechanism, and they have shown that, I want to see how it contributes to other future applications. As I was doing some research, I did notice they have mentioned depression and helping with pain, but I think they should do more studies based on those and see maybe how capsaicin could help with different types of pain levels and maybe how it could help with depression in certain specific ways. and how we could target that, or maybe even other types of cancer cells instead of just the liver ones that we looked at that have G2. So I think all of those should be looked at, and I think that would be some good future research. And here is my reference. Thank you for watching.